Hey there, happy holidays. Welcome to 7-1. We are talking about exponential functions. We'll sprinkle in some exponential equations and some exponential expressions. This is going to be a lot of review from what we talked about in Accelerated Math 3. You'll notice, hey, we're not in my classroom. We are in my dining room. I am filming this video at my home because it is winter break. I am enjoying some time with the family and also getting some time to make these wonderful math videos for you. Okay, so without further ado, let's go ahead and revisit what we did a lot in Accelerated Math 3, or if you're not my student, maybe what you learned in Algebra 2 and Pre-Calculus. All right. So exponential functions. What is an exponential function? Well, it's a function that has a constant base with a variable that is an exponent. And here we have some examples. 2 to the power of x, that's a common base. E to the power of x is probably the most common base that we'll utilize. Okay, and then you can even have expressions within your exponent. Okay, so all of these are exponential functions, and working with exponential functions and equations, you're gonna have to know your exponent properties really, really well. So I'm not gonna sugarcoat this for you. You're gonna have to memorize these, and a lot of these you've been working with, so hopefully you're familiar. Again, bust out the old flashcards, look at some rudimentary or basic foundational examples, and if you want to practice these, you can ask me for a worksheet. I have lots of worksheets that can help you practice these, okay? And I'll just go ahead and recap these. Here we have a base raised to a power of 0. Well, anything to the power of 0 is 1, okay? So you'll utilize that property. If we are multiplying, if you have a product of the same base, okay, you can add those exponents. If you are dividing the same base, you subtract those exponents. Here, if I have a power raised to a power, well, then you multiply those exponents. And the other really kind of foundational one, so I would consider all of these foundational, okay? And I have a negative exponent. Well, you know, if you have a negative exponent, you can move it from the numerator to the denominator, or vice versa, and then you change the sign, okay? 5 and 6 are dealing with distribution. Okay, so we have a power of a product and a power of a quotient. Well, if you have a power, okay, and you have a product on your as your base or a quotient as your base, you can distribute. When can you not distribute? You cannot distribute if you are adding or subtracting, right? So maybe right here. So no distribution when adding or subtracting. Okay, so, and I've talked about this, I know this semester before here. Okay, so an example of this would be like x plus 2 squared, right? That is not x squared plus 4. Okay, so actually I'm going to erase that. Do not write that down. Okay, just note that that's not the case. So let's go ahead and let's kind of practice these skills. Let's dig up your memory. Okay, so here I have a base that is a number 27 raised to the power of 4/3. Well, remember that the denominator is a root, so this is the cubic root of 27, and I'm going to raise it to the power of 4. Well, the cubic root of 27 is 3, and 3 to the 4th power is 81. So there you have it. Example 2, E. Well, remember E is a numerical base. And we'll talk about base E here in a second, which we're going to utilize a lot. It's approximately 2.718. And E plus 1 over E to the power of 0. Well, anything raised to the power of 0 is 1. So, well, that was easy. Number 3. Okay, here I have a lot going on. Simplify everything inside the parentheses first. So we'll start out with the product. Okay, and when you have e to the power of 5 times e to the power of negative 3, you're going to add those exponents. So that is e squared over e to the 4th. Okay, and that is all to the power of 2. Okay, now a couple of ways you can simplify this, and I think the easiest way is to think about it like this, that this is e times e over e times e times e times e, and what you have is you have 2 of the e's canceling out. So this is 1 over e squared squared, okay? But another way of thinking about this is if you're dividing, again, the same base, you subtract those exponents. So that is e to the power of -2 squared, which if we utilize our negative exponent property, we get that there, okay? So either way is fine. I think this way is easier to utilize. Okay, now I have a power of a quotient, and that says that I can distribute. So I have 1 squared over e squared squared. Okay, so I just multiply those powers, and this is 1 over e to the power of 4. All right. Okay. 4 and 5 deal with rewriting exponents. So sometimes when we're dealing with exponential expressions or equations, it's easier just to break down numbers into like kind of like their family base. So notice here I have 5 cubed times 25. Well, 25 is 5 squared. So this is 5 cubed times 5 to the power of -4ths, which is 5 to the power of -1. So our answer is 1/5, right? So that's much easier to deal with. On number 5, okay, I can rewrite this as base 3. So this is 3 squared to the power of x equals 3 to the power of 3. Well, now I have 3 to the power of 2x is equal to 3 to the power of 3. This is known as the exponential property of equality. If I have the left side equal to the right side, their base is the same, then their exponents must be the same. So 2x is equal to 3, which means that x is equal to 3/2. All right? Pretty simple. Okay, let's go ahead and talk about graphing now. So we're going to graph some base functions. And here on number 6, it says, utilize a calculator to graph these functions. So whenever, again, I want to reiterate this for you guys because you guys seem to forget. Whenever it says you may use a calculator or use a calculator, use your calculator. It's okay. Make your life simple. So right now, go ahead, please plot these. I'm not going to graph them because I'm going to graph them here for you guys. But I'm going to use different colors. So I'll graph y equals 2 to the x in blue. Let's put y to the power of, or y equals e to the x, we'll put that in red, and then we'll do y equals 5 to the power of x in green. So I'm going to go ahead and graph these. And what I hope that you've noticed in all these graphs is that we have, I want to find yellow, we have an asymptote at 0. Whoa. All this stuff's popping up. I don't want that. No. Okay. So I hope you notice that we have an asymptote, y equals 0. Okay, for all of these functions, all of these exponential functions. And now, okay, they all have a intercept at 0. Okay, and y equals 2 to the x, that is right here. So our graph looks like this. Okay. I'll go ahead and graph y equals 2 to the power of x. Again, I have an intercept at 1, and that function has a point here at 2.7, so it looks something like this. Okay, a little bit steeper. And then last but not least, y equals 5 to the power of x. Again, an intercept at 0, and we have a point at 1,5. So that function looks like this. It grows very, very steeper, right? And this makes sense. If our base is bigger, I'm multiplying that number over and over and over and over again. Okay, so that makes sense that they're going to grow faster and faster. Okay, let's go ahead and go to the next page. So graphs of exponential functions. What I hope you notice that for a function a to the power of x is that if a is bigger than 1, the domain is all real numbers from -infinity to infinity. I can plug in any input, okay? The range is always going to be 0 to +infinity, okay, unless we have other transformations, which we'll look at in a second. The function is continuous increasing, concave upward, and 1 to 1. So it's going to have an inverse function. The x-axis is a horizontal asymptote, and I went ahead and I plotted that for you. Notice that the limit, okay, as we go to the left is going to approach our asymptote at 0, and our function values, as our x values increase, our function is unbounded, increasing towards positive infinity. Okay, so the last thing to note is that the intercept will always be 0, 1, unless we have transformations, and that the other first point is 1, comma, a. So whatever your base is, that would be a key point, okay? All right, base E. So the letter E used as a base in examples 2, 3, and 6 is not an unknown. It is a number called the natural base for exponential functions, and it's the most common in calculus, okay? And these are nice problems because they're very, very easy to differentiate and integrate, which you'll thank me later, okay? And note that the value of E is approximately 2.718, okay? All right, so here it says, without a calculator, sketch the graph of E to the X. Well, we kind of already did that. Remember that we have an asymptote at 0, a anchor point at 0, 1, and e to the x. Okay, so that's 1, comma, e, which is about 2.718. So our graph looks like this. Boop, there it is. Very easy. All right, example 8. It says, using adjustments to the graph from example 7, graph f of x equals e to the power of negative x plus 1 without using a calculator. Okay, so I'll go ahead, and what I'm going to do here, I'll graph these in stages for you so you can refresh your memory. Okay, so here is y equals e to the x. I'll write that down here. So y equals e to the power of x. Okay, and what I'm going to do now is I'm going to go ahead and graph y equals e to the power of negative x. And if you remember this from Accelerated Math 3, a negative in front of the x is going to cause a horizontal reflection, or a reflection across the y-axis. So our graph looks something like this. Okay. All right, and then I have a k value of plus 1. So that means I'm just going to shift up 1 value. So our graph looks, and we're going to have an asymptote. Our asymptote shifts up as well. So our graph looks something like this. Okay, and there is y equals e to the power of negative x plus 1. Okay, so there's our graphing. And then, of course, here it says write an equation for the graph's asymptote. Our asymptote's at 1, so that is y equals 1. That's our ha. I did it. There it is. Okay, all right. Hey, thanks for watching this video. Again, if you feel like this was a lot, make sure you go back and refresh your memory on Accelerated Math 3 Exponentials. Hopefully a lot of this was review. All right, catch you next time. Peace.